Good afternoon, students. Welcome back to chemistry class. Today we are going to study about modern periodic table. Modern periodic table. It is given by Henry Moseley in 1913. Why modern periodic table was developed? Because the more and more scientists try to arrange the elements in a better way, but they cannot classify clearly that element because the modern periodic table was developed. In previous section we studied clearly about that. According to Anthony Lavoisier in 1789, he grouped the elements into 4 groups: acid making elements, gas like elements, metallic elements, and then earthy elements. And then in 1817, J.W. Dobriner arranged the elements into triads, but he cannot extend this concept. Because of this, in 1862, A.E.B.D. Chancotois arranged the elements into 16 units along the helix on the surface of the cylinder. But it did not attract much more attention. Okay. Because of this, so in 1864, J. Newland made an attempt to classify the elements and proposed the law of octaves. Law of octaves. What do you mean by law of octaves? On arranging the elements in the increasing order of their atomic weight, when arranging these elements, the properties of every 8 elements are similar to the properties of the first element. Okay, the property of the every 8 element are similar to the property of the first element. Okay, but the law of octaves only applicable up to element calcium. Okay, calcium means atomic number 40, atomic weight 40. All the scientists arrange the elements only depending upon the atomic weight. Okay, so for the Newland did not work beyond that. After that, in 1868, the Lothar-Meyer, he arranged the elements depending upon the physical properties and increased the order of their atomic weight. He plotted the physical properties such as atomic volume, melting point, boiling point against atomic weight. Okay, physical properties and the atomic weight, and he get the one of the curve, the same properties of the elements, get the same peak, but there we can't able to find out exact position of that elements. Okay, so to overcome these problems, the Mendeleev periodic table was developed. The Mendeleev periodic table was developed. The Mendeleev listed nearly 70 elements depending upon the physical as well as chemical properties. Okay, so he suggested that he states one of the periodic law, that is, the properties of the elements are the periodic functions of their atomic weight. Okay, arrange the elements in the increased order of their atomic weight shows their physical and chemical properties at regular interval. That is called the periodic law, Mendeleev periodic law. Mendeleev periodic law. He arranged the elements with increased order of their atomic weight because that is atomic number was not developed. Okay. So in the Mendeleev periodic table, this is the Mendeleev periodic table here. How many periods are having? Totally eight groups. 8 groups and 7 periods are having here. The group 8 group subdivided into A and B. The 8th group only, the 7 group, up to 7 group, first, second, third, fourth, fifth and 6th and 7th. Up to 7th group, it can be subdivided into A and B. And the 8th group, it is different. There is, we call this transition series. Okay, 8th group divided into 3 series. Okay. Here, when we are observe the Mendeleev periodic table, the elements of the scandium after calcium, the scandium after calcium did not show the properties of similar to the boron and aluminium. Okay, the scandium it placed above the aluminium and boron, but scandium, properties of scandium differ to the boron and aluminium. It is nearby the boron and aluminium, so the scandium will be the separate group, that is group B. Okay, third group, third B group having the scandium. Okay, the beryllium, magnesium, calcium, strontium, barium having the same properties, so it exists in the same group, second A group. Okay, this is true for all the elements in the periodic table. The properties of the same properties, the elements are arranged in the increase order of the atomic weight, but the same properties of elements arrange the same groups. Okay. But here, when you observe the cobalt and nickel in the 8th group, the cobalt atomic number 15.93, but nickel atomic number is 58.71, but nickel it is placed after the cobalt. Okay, but atomic number it is low, it is less than atomic number of cobalt. Why it exists after the cobalt? Because when comparing cobalt and nickel, cobalt has more atomic weight than nickel, but it is placed in the same group because when we are absorbing the next periods elements, that is cobalt, ruthenium and iridium having the same properties. Okay, like that nickel, palladium and platinum have the same properties. So similar properties elements having the similar group. That's why the cobalt, even having the atomic number low, high atomic number than nickel, the cobalt placed before the nickel. Okay, because of the similar properties of the elements, it exists in similar group. Understood? This is the great achievement of the Mendeleev. And you should observe here having the question mark. You should observe this question mark belongs to the element that would be discovered. Okay, these elements not discovered when Mendeleev arranged the elements. These elements did not discovered. But Mendeleev predict the properties of that elements. Even that element does not discover that times, but Mendeleev predict the properties of that elements. How he predict? Because these elements here before the aluminium, after the aluminium, in the third A group, before the boron and aluminium, and after the boron and aluminium having the question mark, and the fourth A group, carbon and silicon after having the question mark. Because why this question mark means they already Mendeleev predicted here this is the undiscovered element. Okay, but he already predicted the properties of that element. These elements, it is similar to the properties of aluminium, and this element, it is the properties similar properties of the silicon. Okay, so Mendeleev called these two elements Eka aluminium and Eka silicon. Eka aluminium and Eka silicon. What do you mean by Eka? Eka means one. So Eka aluminium means that element that would be discovered. This element, it lies one place below the aluminium. Okay, the element Eka silicon, it means this element placed, it lies one place below the silicon. Because of this name is Eka silicon. Okay, and Mendeleev already predicted their properties. Okay, atomic weight, Eka aluminium atomic weight, Mendeleev predicted it may be 68. Okay, and Eka silicon atomic weight may be 72. And after the discovery of actual element, after some years later, one of the French scientists predicted these elements, discovered these elements, that is Eka aluminium and Eka silicon. There is gallium, Eka aluminium, there is gallium, and Eka silicon, there is germanium. Okay, already predicted. He discovered the elements. These elements, the properties of these elements similar to the Mendeleev properties. Okay, properties predicted by the Mendeleev for the Eka aluminum and Eka silicon. The atomic weight may be 68 and 72. So after the discovery of elements, there is the same, nearly same atomic weight that elements. Okay, atomic weight gallium 70 and germanium 72.59. Like that, the density, melting point, formula of oxide, formula of chloride. Okay, these all properties, that element having the same properties according to Mendeleev predicted properties. Understood? So this is the great achievement of the Mendeleev. The Mendeleev is the very great scientist. For this Mendeleev periodic table, he was honored with Nobel Prize in 1906 for his periodic table. So the Mendeleev periodic table states that, Mendeleev periodic law states that the properties of the element are the periodic functions of their atomic weight. Okay. But in the Mendeleev periodic classification has some limitations. That is, certain elements having similar properties are separated in the periodic table. For example, copper and mercury, silver and gallium having the dissimilar properties, but it have been grouped together. Okay, and like that, copper and silver and gold having the similar properties we know, but these elements grouped apart in the periodic table. Okay, this is the limitations of the Mendeleev. In order to overcome these limitations, in 1913, Henry Moseley classified the elements based on their atomic number. Henry Moseley classified the elements based on their atomic number. Okay, Mendeleev classified the elements based increase in order of their atomic weight. but mostly classification based on increasing order of their atomic number. Okay, so this periodic table called as Mendeleev periodic table. This is the present expected form of periodic table, which includes 118 elements. This is important. The modern periodic table or long-term periodic table, this includes the 118 elements. The mostly arrange the 118 elements in the modern periodic table. Henry Moseley, he was the first scientist to calculate the number of proton in any atoms. You know, Henry Moseley arranged the elements in the increased order of their atomic number. Okay, so the Henry Moseley only first calculate the number of protons or atomic number. Number of proton is equal to atomic number, you know. Okay, so Henry Moseley calculate the protons and calculate the atomic number for any given element. Okay, how he find out the atomic number is the fundamental properties of the atom. He did an experiment. He was studying an X-ray properties with the different element. It corresponds with the atomic number. How he did an experiment? Mostly bombarded the high energy electron. Mostly bombarded the high energy electron. High energy electron means from a heated, it becomes from a heated filament. Okay, from a heated filament, it becomes the high energy electron. This high energy electron strikes on different elements. Okay, different elements. You take the elements. For example, I am taking the element, for example, aluminium. I am taking aluminium, one of the element. When he bombarded the high energy electrons on the element, this caused X-ray rays to be released. X-ray rays to be released. The different amount of X-rays were released depending on the size of the atomic number. Thus, Moseley predicted the atomic number. Understood? Okay. The more protons there were, the high frequency X-rays were released. For example, I am taking the aluminium, one of the element, and potassium, another one element, and fluorine, another one element. Aluminium atomic number 13, potassium atomic number 19, fluorine atomic number, iron atomic number 26. Okay, here aluminium, it is the number of protons low when compared to potassium and iron. When Moseley bombarded high energy electron on the aluminium, it released the X-ray frequency of the X-ray release. When comparing aluminum and potassium, aluminium released the low X-ray rays. Okay. When comparing potassium and iron, potassium release the low frequency of X-ray, and comparing the iron. Iron release high frequency of X-ray, high rays, more rays released from the iron. Understood? The more protons are there, it releases high X-ray frequency. From that, mostly predict the atomic number, means number of protons. Okay, the amount of X-ray given off were proportional to the atomic number of whatever element it was. For every increase in proton, there was a direct increase in X-rays given off. From this experiment, mostly concluded the atomic number was equal to the number of protons of atom. Okay, so he discovered this from the study of frequencies of X-rays emitted by the elements. Okay, from this experiment, he studied the frequency of X-rays emitted by the element when bombarded with the high energy electron. It emits the X-ray frequency. Okay, so the frequency of X-ray is proportional to the atomic number. Okay, so the root of frequency, it is equal to A into Z minus B. Here, nu means the frequency. Nu indicates the frequency. And Z indicates the atomic number. And A and B, it is the constant. Okay. Nu is the frequency of the X-rays emitted by the element with atomic number Z, and A and B are constant. Okay. So mostly how predict the atomic number is the fundamental particle of an atom. He plotted the curve against frequency of an element and then atomic number. Okay, the frequency, he take the root of frequency, he take in x-axis, and the atomic number he take in y-axis. When he plotted the curve, he get the straight line. Okay, when number of frequency increases, atomic number increases. Okay, he get the straight line. But when he plot the curve against the frequency and atomic weight, frequency, he take the x-axis and atomic weight taken as the y-axis. When he plotted the curve, he get the zigzag curve. Okay. So, he find out the atomic number, it is the more and more fundamental property than atomic number. Okay. So, from this X-ray experiment, he believed the atomic number is the more fundamental property for any element rather than atomic weight. Okay, understood? So the plot of the root of frequency and Z gives a straight line. Using this relationship, we can determine the atomic number of an unknown element from the frequency of X-ray emitted. How much X-ray emitted? We can get the atomic number of an element. Based on his work, the modern periodic law was developed. Based on his work, the modern periodic law was developed, which states that the physical and the chemical properties of the elements are periodic functions of their atomic numbers. What do you mean by modern periodic law? The physical and the chemical properties of the elements are periodic functions of their atomic numbers. Okay, this is the modern periodic law. But we studied about the Mendeleev periodic law. What is the Mendeleev periodic law? The properties of the elements or the periodic functions of their atomic weight. But according to the modern periodic law, the physical and the chemical properties of the elements are the periodic functions of their atomic number. Okay, understood? So what do you mean by periodic function? Periodic function mean that is the elements which occurs of regular intervals. Okay, the arrange the elements in the increased order of their atomic weight shows their physical and chemical properties at a regular interval. That is called, means periodic function. Okay, according to Mendeleev, what is the periodic law? Mendeleev periodic law, the physical and chemical properties are the periodic functions of their atomic weight. Okay, so according to modern periodic law, very, very important, the physical and the chemical properties of the elements are the periodic functions of their atomic number. Okay, periodic functions, it explained by the periodicity. Periodic functions explained by periodicity. What do you mean by periodicity? The repetition of physical and chemical properties at regular intervals is called periodicity. Okay, what do you mean periodicity? The repetition of physical and chemical properties. The repetition of physical and chemical properties at regular intervals. At regular intervals is called periodicity. Okay, when we are here, this is a modern periodic table. You see here, this lithium, beryllium, boron. They arrange the elements in the increased order of their atomic number. The lithium atom number 3, beryllium 4, boron 5, carbon 6, 7, 8, 9. This is based on atomic number. Okay, atomic number. Here, the lithium, beryllium, boron. The lithium has the different chemical properties than lithium is the different chemical properties than beryllium and boron and carbon, nitrogen, oxygen, fluorine, neon. After that, the atomic number 11, that means sodium. Sodium, below the sodium, potassium and rubidium, cesium, francium. These all elements, this is called first group elements, we called. These all elements have the similar properties. Okay, so periodicity means the physical and chemical properties of the elements. Physical and chemical properties of the elements at a regular interval. Okay, at a regular interval, that is called a periodicity. Okay, lithium and sodium has the similar chemical properties, but it becomes at a regular interval. After the neon, the sodium is the chemical property. Okay, when we are arranging according to the atomic number, the physical and chemical properties of the elements, it becomes after regular interval. Clear? Okay. So here about the periodic table, this is the modern periodic table. All the elements are arranged in the modern periodic table, which contain 18 vertical columns. Okay, this is the vertical columns. How many vertical columns are there? 18. 18 vertical columns and horizontal, 7 horizontal rows. 18 vertical columns and 7 horizontal rows. Okay, according to Mendeleev periodic table, this is how much vertical columns there are? 8 vertical columns. 8 vertical columns and 7 horizontal row here. According to modern periodic table, here 18 vertical columns and 7 horizontal rows. The vertical columns are called groups and the horizontal rows are called periods. Okay, vertical columns are called groups and horizontal rows are called periods. Okay, The groups are numbered 1 to 18 in accordance with the UPSC recommendation, which replaces the old numbering scheme of 1A to 7A, 1B to 8B, 7B and 8. Okay, this is the old numbering system. It is according to the mentally periodic table, numbering 1A, 2A, 3A, okay, to 7A and 1B to 7B, after that 8. This numbering system are replaced by the UPEC. Okay, so groups are numbered to 1 to 18. 1 to 18. Okay, not confusing there. 1 to 18. Numbering give to the IUPAC. Okay, so here the periodic, this is the 18 group and the 7 periods are there, and also it is divided into 4 blocks. The periodic table also divided into 4 blocks. What are the 4 blocks? S block, P block, D block and F block. S block, P block, D block and F block. Okay, S block means, what do you mean by S block? S block means when outermost electron, okay, when outermost electrons is present in s orbital. Outermost electron present in s orbital means S block elements. Here the first and second group elements we call as the S block element, and P block element means when outermost electron are entering in the P block elements, we call as the P block elements. Okay, here group number 13 to 18, this called the P block elements. Okay, last the 18th group element, otherwise we called as the zero group element, are noble gases. Okay, noble gases. 18 group elements we called as the noble gases. It does not react with any other elements. We studied about that clearly. Okay, so the D block element means the middle elements, group 3 to 12. Group 3 to 12 we called as the D block element. Also we called as the transition element. This D block element also called as the transition element. P block elements we called as the representative elements. Understood? And then the down of the periodic table have the 2 periods, but it is not here. This is the place, but this place, this we call as the F block elements, because the outermost electron enter into the F orbital, so it is called as the F block element, but it plays in the 6th period and the 7th period. Okay, this is the period. How many periods? The left to right. Left to right we called as the periods. So horizontal rows are we called as the periods. Here totally 7 periods are there. But here the down the periodic table have lanthanides and actinides. Lanthanides and octinides. The lanthanides and octinides it plays in between the transition elements. Okay. See here. This is the lanthanide 57 and cerium 58 to 71, cerium to lutetium, and 72 hafnium. So these lanthanides placed in between the here the 6th period, in between the lanthanum and the hafnium. Okay, and the actinides, thorium to lawrencium, the actinium atomic number 89, thorium 90, 92, 103, it occupy here. This is the place, 7th period. 7th period number 7 is the place for the octinides. Okay, so otherwise we call it as the inner transition element, because it is placed in between the transition elements. So these 2 elements, 2 rows, we call it as the inner transition elements. Okay, understood? So these are about the periodic table, modern periodic table. Here, the each period start with the element having general outermost electronic configuration. Here, see here, this is the period 1 to 6. This is the period. Period number 1 means hydrogen. Suppose sometimes the place before the lithium because it occupies the 1s1 orbital. So here this is the place for hydrogen, one of the isotopes. So it will be here. Okay, so here lithium, it is start from 2s1. Okay, 2s1 and ends with 2p6. Okay, 2p6. And the sodium start from 3s1 to 3p6. Okay, 3s1 to 3p6. After that, the potassium start from 4s1 to 4p6. Okay, so here the each period start with the element having general outer electronic configuration ns1. So each period start from general outer electronic configuration, that is ns1, and ends with np6. Understood? Here n corresponds to the period number. We know that is principal quantum number. And this modern periodic table, it arranged according to the Alpha principle and the electronic configuration of atoms. Provide the theoretical foundation for the modern periodic table. Understood? So here the physical and chemical properties of the elements are correlated to the arrangement of electrons in their outermost shell. Okay, the physical and chemical properties of the elements are correlated to the arrangement of electrons in their outermost shell. Valence outermost shell means valence shell. Different elements having similar outer shell electronic configuration possess similar properties. Okay, so here, see here having the different elements. Okay, lithium, sodium, potassium, rubidium, cesium, francium, all these different elements, but it shows the same chemical properties. Okay, similar properties. These elements are grouped together in the modern periodic table. Okay, so the first group elements are the similar physical and chemical properties. Second group elements also similar physical and chemical properties. Okay, because it ends with s orbital. Okay, for example, the electronic configuration of first group elements we called as the alkali metal. Second group elements otherwise we called as the alkaline earth metal. Okay, first group S block element, first and second group elements we called as the S block element. The first group elements we called as the alkali metals, and this is alkaline earth metal, and P block element representative element, and D block element transition element, and F block element N transition element. These are the name of these periods. Okay, here elements in group 1, lithium atomic number 3, so electronic configuration 2, 1, so valence electronic configuration 2s1. Like that, sodium atomic number 11, number of electrons in the valence shell 2, 8, 1, so valence shell configuration 3s1. Okay, valence shell means, what do you mean by valence shell? This is the outermost shell electron. Like that, potassium atomic number 19, number of electrons in various shells in order K, L, M and MP, that is 2, 8, 8, 1, because atomic number 19, the valence electron 4s1. Rubidium atomic number 37, electronic configuration 2, 8, 18, 8, 1, valence shell 5s1. Okay, cesium 55 atomic number 2, 8, 18, 18, 8, 1, so valence shell 6s1. Francium 87 atomic number 2, 8, 18, 32, 18, 8, 1. Okay, so valence electronic configuration 7s1. Okay, these are about the electronic configuration. So based on the electronic configuration, the elements are arranged. Okay, electronic configuration means there is depend upon the atomic number. Okay, students, today assignment, today also two small question. What is the modern periodic law? And second question, what is periodicity? 2 question, very very important for the 2 mark question. Okay, what is periodic law? Modern periodic law. Okay, Mandalif periodic law yesterday we studied. So today, what is modern periodic law? After that, what is periodicity? 2 question you should study. Okay, study and write and send me through WhatsApp number. And if you having the book, take your book now, page number 73. Okay, students, take page number 73. Today's assignment, what is the modern periodic law? Page number 73, the left side of the page, second paragraph, third line, onwards how to mark. The physical and chemical properties of the elements are the periodic functions of their atomic numbers. Okay, up to here your mark. After that, what is periodicity? Periodicity means the last 3 lines. Okay, same paragraph, last 3 lines. The repetition of the physical and chemical properties at regular intervals is called periodicity. The repetition of physical and chemical properties at regular intervals is called periodicity. 2 questions, very very important. Study, and if you can study, you study the periodic classification, the modern periodic table, page number 74. Just study. If you can study, you should study the first 30 elements. Okay, you should study first 30 elements. Okay, what is the first 30 elements? Lithium, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Up to here you should study. Very very important for your further studies. Thank you all of you. Thank you.